So today what I want to look at is a proof that says the norm of any unit vector has a length of 1. So what does that mean? Well, let's say we have some vector x here, and x is going to be defined by a, comma b, comma c, comma d, and it's going to go on and on and on. Now, a norm is defined by the norm of x is equal to the square root of a squared plus b squared plus c squared plus, and then it's going to go on and on. So this is our unit vector, which is going to get its definition from x and the norm of x. And unit vector is here in red. It has the same direction as x, but it has a magnitude of 1, and we're going to prove that its magnitude is always 1 for any case except for where x is the 0 vector, because this case would be completely irrelevant there. So x hat, which is our unit vector, is defined by x over the norm of x. And we want to take the norm of this and show that the norm is equal to 1. So let's start off with the norm of x over the norm of x. And what we're going to do is we're going to look at a different definition of the norm. It's the same thing, it's just expressed a little differently. So we have a squared plus b squared plus c squared, and that's going to continue. And we know that this is what x is. But by looking at our basic definition of matrix multiplication, we can say that this up here is equal to what I'm going to write under this radical in blue. So we have x transpose x. Well, that's just our simple dot product. That's just a simple dot product of x and x. So we're going to be able to apply use to this in the proof that we're going to be doing. So with using this definition, we can rewrite what's in here as the square root of 1 over the norm of x times x transpose times 1 over the norm of x times x. So let's rewrite this using a little bit of algebra. And, well, 1 over the norm of x is just a constant, and the transpose of a constant is the same exact thing that you took the transpose of. So we can rewrite what's under this radical as the square root of 1 over x, the norm of x, times x transpose 1 over the norm of x times x. So we have 1 over the norm of x in here twice. So we could simply group this here together, and we can say the 1 over the norm of x squared. Now we have a squared on the bottom here, so these two are going to combine to form 1 over the norm of x squared. Now this is under a radical, so we can pull this outside and just get 1 over the norm of x. So we can rewrite this as 1 over the norm of x square root x transpose x. So what is the square root of x transpose x? Well, that's essentially what we just did up here. X transpose x square rooted is going to be equal to the norm of x. So that means that we can simply rewrite this as the norm of x over the norm of x which is equal to 1. And that's a very nifty, clean proof that gets you a nice little result there. That any unit vector has a length of 1.